And we welcome you back. So in this video, we take a look at alternating series to determine if they converge absolutely or if they converge conditionally. And so some definitions are in order. We say that a series is absolutely convergent if the sum of the absolute value of the a sub n's converges. What does that mean? It means if you take away the alternation, it converges anyway. That's what that means. If the sum of the a sub n's converges, but the sum of the absolute values of the a sub n's does not, then we say that the series is conditionally convergent. The condition, it depends on the alternation. If the series needs the alternation to converge, we say that the series is conditionally convergent. Doesn't mean that it's less convergent, it just means that it needs the alternation to converge. It would not converge otherwise. So let's revisit the three questions from our previous video. All three of these series converge. Would they have converged anyway? So take a moment, think about, would this have converged anyway? Would this have converged anyway? Would this have converged anyway? Make decisions about whether or not these are absolutely convergent or conditionally convergent. Okay, we know that 1 over n is a p-series and p is not bigger than 1, so the 1 over n's would not have converged anyway, so the red series is conditionally convergent. Similarly, 1 over n cubed, that's a p-series, p is bigger than 1, and so the 1 over n cubed would have converged anyway. So the blue series didn't need the plus minus plus minus. The blue series is absolutely convergent. So what about green? Well, this is not a p-series, but we can do a limit comparison with a p-series, or we can do an integral test, and we can find out that this would diverge. It's by limit comparison with 4 over n, or by the integral test, this diverges. So this green series needs the alternation to converge, so the green series is conditionally convergent. So let's set you up. Which of the following are absolutely oh, that's just terrible. Are absolutely convergent, which are conditionally convergent, which diverge. So we've got the sum of the negative 1 to the n plus 1, 1 over root n. We've got the sum of the negative 1 to the n plus 1, n plus 1 over 3n plus 10. We've got the sum of the negative 1 to the n plus 1 times 1 over n squared. And we've got the sum of the negative 1 to the n plus 1 times 3 to the n over n factorial. Think for a moment. Hit the pause button. because in 5 seconds of video time, you're going to see an answer. Hopefully you got those 4 answers. 1 over radical n is a p series where p is a half. That's not greater than 1, so it needs the alternation. And 1 over n squared is a p series. P is greater than 1. That would have converged anyway. N factorial grows much faster than 3 to the n. These settle down really, really quick. So this is absolutely convergent. And the nth term here goes to 1/3. So this eventually becomes minus a third plus a third, minus a third plus a third, minus a third plus a third. That never settles down. So the extra piece in this video is all about knowing if they would have converged anyway, regardless of the alternation. And I hope that's pretty clear to you.